In 1959, Louis Leakey and his wife Mary changed the scientific vision of world history when they discovered the remains of an ancestral human who lived in Africa almost 2 million years ago. Since 1931, Leakey had been finding what he believed to be primitive stone tools at Olduvai. But it was the discovery of the fossilized bone with the chipped stones that proved human toolmaking extended back to an unbelievably distant past. The Leakeys got an age range of around 1.1 million years when they used an experimental dating method. Fission track dating was a new technique that tested radioactive decay in mineral crystals found in the layers of lava and volcanic ash overlying the bones and artifacts. In the same year, perhaps even the same field season, one of the great coincidences in archaeological science occurred on the other side of the globe. In 1959, Juan Armenta Camacho, a gifted amateur, discovered stone artifacts and fossilized animal bones that were eroding from the banks of the Valsequillo Reservoir in central Mexico. The finds from Africa and Mexico shared many similarities, but what subsequently happened with each discovery was dramatically different and remains one of the most intriguing episodes in archaeological history. Near the city of Puebla, about 70 miles east of Mexico City, a number of ancient volcanoes rise from the Central Plateau. The region was known to the Aztecs as a land of giants. When the Spanish began digging their foundations for their 17th century cathedrals, they had unearthed the bones of large mammals unlike anything they had ever seen. By the 1950s, paleontologists had known for decades that the shores of the Valsequillo Reservoir were a rich source of Pleistocene fossils, the bones of large mammals that had lived in the region long ago but became extinct at the end of the last ice age. During the field season in 1959, Juan Armenta Camacho found the artifact that launched one of the New World's most controversial scientific mysteries. As he began to clean a fragment from an ancient mastodon bone, he discovered artwork. He saw the engraved images of several different animals that lived during the last ice age. It was possible that he was holding one of the oldest human artifacts found in the New World. Today, no one seems to know where this artifact is. At the time he found it, Armenta knew what a good scientist should do. He kept the artifact a secret, but began to invite preeminent specialists to verify the discovery. Microscopic studies of the engraving showed that the bone had been engraved when it was still fresh, what the paleontologists call green bone. This indicated that the artist worked soon after the animal was killed, and the artifact was not a recently drawn fake. But how old was it? In 1926, J.D. Figgins, who would eventually bring Marie Wormington to the Denver Museum, broke through the theoretical floor of the American archaeological past. He proved that humans had lived in the New World during the Ice Age, the time of the giant mammals. At a site in Folsom, New Mexico, he discovered a man-made spear point among the bones of an extinct bison antiques. At the time, scientists believed that humans first arrived in the New World about 4,000 years ago. With the discovery of the Ice Age American, human occupation was pushed back to a date which at the time researchers thought might range between 20 and 500,000 years ago. In 1926, no one knew how long ago the Ice Age actually occurred. About 25 years later, Willard Libby developed the technology of radiocarbon dating, which, combined with modern pollen analysis, told scientists that the last ice age and its megafauna started to vanish around 14,000 years ago. In the late 1950s, the new carbon dating technique was gaining wide acceptance, but Armenta quickly realized that he could not use it. His artifacts had been in the ground for so long that their chemical composition had changed from organic bone material to mineralized fossil, which contained no carbon compounds that could be tested by radiocarbon dating. Armenta recognized that, if authentic, this artifact could be the oldest artwork ever found in the New World. In an effort to authenticate this amazing find, Armenta enlisted help from paleontologists, professional artists, geologists, and archaeologists from all over the world. One of the first on the scene was famed Paleo-Indian archaeologist Dr. Hannah Marie Wormington. After meeting with Armenta and examining his collection, she was convinced that the Valsequillo artifacts were an extremely important find. Meanwhile, word of the discovery leaked out to the press, and in the summer of 1960, Life magazine published a feature article about Armenta and his site. The now famous engraved mastodon bone was sent to the Smithsonian Institution for public display. On the same day the Life magazine article was published, Wormington wrote to her protege, Cynthia Irwin, describing her impressions of the site and hinting at its potential significance. Hannah Marie Wormington was one of the first scientists who came to view Armenta's collection. Wormington had always been a pioneer. When she began her studies in 1937, women were not yet allowed in the Department of Archaeology at Harvard. Undaunted, she sat outside on the steps of the lecture hall to take notes. Wormington began mentoring Irwin when Cynthia was a teenager. Cynthia's mother also had a strong interest in archaeology. Kay Irwin was an innovator in the casting of artifact reproductions. She specialized in adding the artistic touch of perfect color duplication when she recreated the flints, cherts, and other stone materials of the past. In the mid-1950s, Marie Wormington was writing her masterpiece, the fourth edition of Ancient Man in North America. Barely out of high school, Cynthia was entrusted with the index. The fourth edition was the first major synthesis of paleo research to include the new radiocarbon dating method. When it was published in 1957, it became the widely accepted foundation of a new scientific vision based on calculable time. To professionals and the public, she effectively communicated the idea that the record of paleo peoples in the New World began around 12,000 years ago. Wormington was optimistic that the new technologies would lead to further discovery. She knew that the Valsequillo site would require careful excavation, and her protege, Cynthia Irwin, was ready to lead the team. In 1962, Cynthia Irwin was 1 year shy of marriage and her Harvard PhD, and had already led several world-class digs. She was granted a permit from the Instituto Nacional de Antropología y Historia, known as the INAH. Along with Juan Armenta, she began her first field season at Hueyatlaco, on the shores of the Valsequillo Reservoir.
She went down there for 3 years, 1962, 64, 66. She organized probably one of the first interdisciplinary archaeological expeditions, at least in Mexico, looking for early man in America during the Ice Age. Interdisciplinary means that it wasn't just an archaeologist going down looking for artifacts. She brought along Smithsonian paleontologists and geologists from the U.S. Geological Survey, the tops in their field.
The site, called Hueyatlaco, on the banks of the Valsequillo Reservoir, was once the channel of an ancient stream. Cynthia chose a spot to excavate not far from where Armenta had discovered the engraved bones. The site turned productive very quickly. Stone spear points were uncovered, and Cynthia's team began to carefully record the positions where the artifacts were found.
So this is Cynthia's trench wall. The sites that were chosen all were productive, all had artifacts, and all were associated with Ice Age animals. So it was an incredible beginning in 1962.
Eventually turned out to be one of the most controversial sites that's been excavated, and one that we have not resolved the issues. The site is stratified. In other words, younger stuff's at the top, and you just dig on down through lower stuff. And these are casts of the artifacts, starting up here with the upper Hueyatlaco Unit C is the youngest, and then this material down here from El Horno is the oldest. And that makes perfectly good sense, because this type of projectile point, it's bifacial, it's flaked on both sides, and it's bipointed. And to my way of thinking, this is an Asian style projectile point, because it's very thick relative to its width, and it's pointed at both ends. And we can follow this style of projectile point all the way back into Siberia. But we see these in South America starting around 12,000, between 13 and 12,000. And so to find this at roughly that same age in the Valley of Mexico makes perfectly good sense.
One of the interesting parts about these spear points was that they did not have the customary flute that was essentially the earmark of Clovis points. So she knew she wasn't dealing with a Clovis culture here.
Beneath the volcanic layer, called the Hueyatlaco ash, are deposits of clay. Beneath those layers are beds C and E, where Irwin-Williams found bifacial spear points and Ice Age animal bones. Beneath that was bed I, where the older unifacial spear points were found.
So they started excavating down below, and then all of a sudden they started getting these very interesting flint artifacts. And these are projectile points that are unifacial. In other words, actually they're not even bifacial. They're just pieces of flint that have been shaped to a sharp point with these steep flakes going all the way down here, all the way down there, and that's all they could do to make the artifact. And these were found with mammoth bones, with camels, with horse, all kinds of animals that are now extinct.
Cynthia personally excavated each artifact as it was found. The stratigraphy and the relative positions of the stone tools made sense to her. It is generally accepted that bifacial tools were more complex, and the bifacial tradition more recent, than simpler unifacial tools that would be found in the earlier, lower levels of geological time.
This led her to conclude that she had perhaps technological evolution occurring at this site. She had excellent bifaces on top, and she had unifaces on the bottom, all associated with extinct Ice Age animals. It couldn't have been better. The problem was dating. The bones were so fossilized, their organic materials had been replaced by minerals, preventing C14 from being used on these bones. There just wasn't enough organic material left to date.
Cynthia believed they needed to find another site, away from the edges of the water, where the bone might not have become fossilized as quickly. Hal Maldy of the United States Geological Survey was the project's geologist. Maldy had worked previously with Cynthia Irwin-Williams at a site called Hell Gap in Wyoming, and had looked for early man sites in China with Wormington in 1975 for the National Academy of Sciences.
Because neighboring volcanoes, both to the west and to the north, that there was a lot of volcanic material around, and I saw the need to extend the geologic investigation of the valley proper out onto these volcanoes to see whether I could relate the volcanic events, the eruption materials, primarily volcanic ash, to things that we were finding out there in the valley.
So in 1966, Hal Maldy, the geologist, found about 3 or 4 miles away stratigraphy in a deep wash called Colopan. He found some stratigraphy or a layer of soil that he thought was of the same age and of the same nature as the materials they were digging out at the reservoir. What he found was a flake that may have been a scraper, some shell, and some organic materials in the soils.
Using the carbon-14 dating method on the shell from Colopan, a date of 22,000 years was derived. As radical as it seemed, the age of 22,000 years would eventually become one of the most conservative estimates for earlier humans at Valsequillo.
As a matter of fact, if it's only 22,000 or 24,000, as she originally thought, that's really interesting too, because it's totally different than anything we're getting at that age as well. And it is much older than anything we have in North America right now, by at least 6,000 years.
This young graduate student has found probably the earliest site in the New World. Was she right? Was she correct? How did she feel about this? She was nervous. If anything, Cynthia was extremely responsible as a scientist. She didn't want to go grandstanding and go blabbing to the news. In fact, we have a letter where she's writing to the director of the Peabody Museum, a Dr. Brew, where she doesn't want to go public with this yet. She's feeling very uneasy about these dates because of their great antiquity. As a result of that letter, though, Dr. Brew apparently went public with those dates and announced those dates. And this was probably in 1966 or early 1967.
Williams immediately knew that a 22,000-year date paralleled the oldest known spear points found in the Old World. This meant that if the spear points found at Hueyatlaco were any lower in the strat column than Colopan, she would have to face the unthinkable, that she had found the oldest spear points ever discovered in the New World. As controversial as this date was, it was nothing compared with what was yet to come. The release of the 22,000-year date triggered an avalanche of unexpected events. At the height of Cynthia's most productive season, her work at Valsequillo came to an abrupt halt. Dr. Jose Luis Lorenzo, head archaeologist at Mexico's National Museum, published a bulletin accusing Irwin-Williams of planting her discoveries. Then, according to eyewitnesses, Lorenzo visited the site and, accompanied by armed federales, interrogated the workers, trying to elicit confessions that they planted the controversial spear points. Juan Armenta's daughter, Celine, remembers those days.
The scientific authorities sent some men with pistols to try to scare the workers at the field. And they were about 60 workers. But 3 of them accepted that the fossils were planted. And only these 3 people who signed the paper and saying, yes, we planted, and the scientists planted the fossils. The other 50 and more workers never accepted. They were very honest.
Jose Lorenzo, who was the Mexican archaeologist, who's well known for his Paleo-Indian work, of course, I think was a little jealous that, 1, he didn't find that early stuff, 2, that it was an American that found it, and 3, it was an American woman that found it. And so he did everything he could to discredit Cynthia and the work, and Juan Armenta, to discredit Juan Armenta. And I think the work was good.
I don't think she was directly accused of planting the artifacts herself. Instead, it may have been something much worse, that she was incompetent to realize that artifacts were being planted on her site. And this goes back to the logistics of planting. These sites were all very hard sediments. They were not dirt like you usually see archaeologists digging in your science films. This was almost like paleontology or geology in the sense that the material, if it wasn't rock, it was almost rock. They had to use picks and chisels rather than the trowel, which is the standard archaeological tool. Consider a sidewalk, and you're trying to tell an archaeologist, or you're trying to convince an archaeologist that something in that sidewalk has been planted. This means you got to break open that sidewalk and try and cover it up, and so that the archaeologist believes that what they're coming upon is something that hasn't seen the light of day for as long as it's been buried. Having worked down there last year and experienced the density and the hardness of the sediments, both the Mexican archaeologists and myself agreed there's just no way you could plant artifacts in this material and hope to get away with it.
Marie Wormington quickly moved to her protege's defense. In the fall, she organized a professional conference, essentially to defend Cynthia against the claims of fraud. The archaeological professionals closed ranks behind Cynthia, confirming the validity of her excavation work.
As Dr. Stanford remembers, she was one of the greats in instituting new techniques, new scientific techniques for recovering the most minute detail. And this was one of the wonderful elements she brought to her profession and why she was so highly regarded for her entire life.
They owned the artifacts. She was working under a permit that these artifacts belonged to the Museo Nacional in Mexico City, where some of them worked. And so when she left, she deposited these along with the bone at the museum. And when she went back to study them, they were all gone. And they've never been seen since. Now, fortunately for all of us, her mother was with her, and while she was in Mexico, she cast those artifacts before they were given back to the museum. And when she died, her collection came here. And so this is all that is left of that excavation, is what's these plastic artifacts in this box. So right now, the important thing is Cynthia's now passed away, as have the archaeologists in Mexico that were basically jealous of her finding this real early stuff. And so now it's time to go back and reassess what actually went on there.
In spite of the support Irwin-Williams received from Wormington and her peers, the controversy about the artifacts was soon to escalate when new dating techniques were applied. In an attempt to accurately determine the dates, 2 geologists from the United States Geological Survey were brought in. Barney Szabo ran tests using uranium series dating, while Virginia Steen McIntyre examined zircon crystals using her expertise in tephrochronology. No one was prepared for the shock when Barney Szabo announced a uranium series age of 250,000 years old. At this point, Irwin-Williams went from potentially making history for redating the arrival of man in the New World to facing dates that were so extreme she felt they could not be published at all. But more important, she was denied permission to ever work at the site again. Her official report was never completed. All of the artifacts have gone missing, and the site was closed to further investigation. The story of Irwin-Williams and Armenta's historic discoveries has almost been forgotten, as the memory of the scientific uproar of Valsequillo has faded away. 40 years have passed, and although many prominent archaeologists still believe that the Hueyatlaco site contains important evidence, it took one man's vision and tenacity to reignite the investigation.
So we need a breakthrough site like Hueyatlaco, which just jumps you back here, and then you've got to start rethinking and reconstructing everything.
In 1997, George Carter, an archaeologist with a long career of investigating controversial cases, called upon his friend Marshall Payne to reopen the Valsequillo site and to underwrite a new series of field tests.
And then they said, well, how'd you get interested in Hueyatlaco? I says, well, George Carter called me one time and asked me if I wouldn't look into that. And he says, something like, what are you going to do next time? I says, I'm not answering the phone.
Historically, many of the great advances in American science have begun with the entrepreneurial dreams of financial patrons from outside the profession. For example, today's most widely held theory for the peopling of the New World across Beringia was advanced at the beginning of the 20th century by collaboration between science and private philanthropic support. Before the Russian Revolution closed the northern borders to scientific exchange, Franz Boas from the American Museum of Natural History launched teams of anthropological researchers into Alaska and Siberia. The expedition was underwritten by a New York financier by the name of Morris K. Jessup. Information from the famous Jessup expedition helped solidify the idea of cultural and biological connections between peoples across the North Pacific Rim. 100 years ago, Boas's scientific vision, financed privately by Jessup, became a foundation block for the emerging hypothesis that the first Americans came from Siberia. This concept would eventually become the reigning paradigm. In 2001, a new archaeological expedition combining Mexican and U.S. scientists was organized to go to Valsequillo and reassess the results of Cynthia's earlier work.
What I intended to do is to redo what was done many years ago by Cynthia Irwin-Williams, but to use more modern techniques in the evaluation of what was done.
Most scientists accepted that the artifacts were real. It was the age of the site that ultimately created the greatest controversy. The new research team devoted itself to reanalyzing the entire sequence of dating events, beginning with the first arguments against the Calopan dates.
There was a number of complaints when this 22,000-year-old date was published. It wasn't so much the date that was being criticized, but the fact that the date comes from a sedimentary or a soil profile miles away from the actual site. And there were some geologists that criticized the judgment that the Calopan site, from where the dates came from, was actually the same stratigraphy from which the Ice Age animals with the artifacts were coming out of at Valsequillo Reservoir. And in fact, some geologists were pretty close to proving that these are two different layers, therefore bringing problems into that association. It's an indirect association. When you go to a site miles away and take a date out of a layer of soil and then try to associate that to another sedimentary bed miles away, and especially in such a significant discovery as this.
In 1968, a new and still experimental dating method was used directly on the bones that Cynthia found with the tools. Charles Naser, a dating specialist with the U.S. Geological Survey, joined the effort.
The dating of this site started off when geologists working with anthropologists collected bones from large mammals that were associated in the same layer as the artifact tools. These bones were given to Barney Szabo at the USGS in Denver. He was involved with a technique called uranium series disequilibrium dating.
As uranium decays by alpha emission, new daughter elements, such as thorium-234, are created. This process continues over time, with both elements accumulating. By measuring the amounts of the new daughter elements and comparing it to the amount of uranium that was present, an age can be calculated.
Barney's ages were all in excess of about 100,000 years to in excess of several 100,000 years. So we don't know what the top end on a lot of Barney's ages were, but we know that they were greater than, certainly greater than 100,000 years.
So this was a bombshell.
100,000 years was far earlier than most scientists believed the first humans would have been capable of reaching the New World from Asia. The uranium dating of the bones was just the beginning of a series of tests using new dating techniques. In 1966, the project's geologist, Hal Maldy, had been joined by Virginia Steen McIntyre. McIntyre was a young graduate student who specialized in the new technologies used to date layers of volcanic ash. The different layers of ash, or tephras, which could be seen as outcrops around the reservoir, were the result of different volcanic eruptions over time.
It's a messy business, geology.
The volcanic ashes at the site occur above the artifact layer. That means that they were deposited in geologic time more recently than the time that the gravels of the artifact-bearing and bone-bearing bed were deposited. They are, in fact, younger than the bone-bearing, artifact-bearing bed.
If geologists could calculate the date of the volcanic eruption by analyzing the ash layer, they would then know that the tools found below the tephra were even older. McIntyre used an experimental dating method that calculated the trace elements of water trapped in crystals that formed with the ash.
That's a piece of pumice. Lightweight, probably would float on water. Little tiny crystals in there are crystals that I work with. So small, they're smaller than grains of sand.
Although her method at the time was very experimental, she too got an age in the range of 250,000 years, far too early for the accepted dates of humans in the New World. This led to further testing of the volcanic ash layers.
So geologists again collected some volcanic ashes from layers that are in known relationship to the artifact-bearing beds. And they separated a mineral called zircon from these beds and gave me the little tiny crystals, size of grains of sand, to date with the fission track technique. Fission track dating relies on a very rare event that happens to uranium atoms.
When a volcano erupts, it forms zircon crystals and volcanic glass, in which are trapped uranium-238 atoms. The uranium spontaneously decays, releasing energy when splitting into two roughly equal nuclei. These highly charged particles repel each other and shoot off in opposite directions with great force. This leaves behind damage scars or fission tracks in the mineral. Because the radioactive decay occurs at a known rate, the density of fission tracks can be compared to the amount of uranium within a mineral grain to determine its age.
My ages came out on two different samples of about 400,000 years and about 600,000 years. These ages had very large errors, which means they could have been anywhere between probably 200,000 and 800,000. They could not have been 10,000 or 15,000. There was just too much antiquity in the grains to allow them to be that young.
What happened to these findings of yours?
It just appears that it just went off into a black hole. The data never ever gets cited. Nobody ever talks to me about it. It's just as if we had never done it.
Well, we have it in Cynthia's own writing that those radical dates are not to be used because they're too young and too unreliable. What would be your comment?
At the time that this work was begun, they were relatively new, but they had been well tested in the geological literature and geologists accepted their results as valid.
So how surprising is this, Chuck? Didn't you tell me that you were involved in the Olduvai discoveries in Africa with your dating?
About the same time, I got involved with dating zircons from the Olduvai site. The Olduvai site itself was controversial in the late 60s. Early potassium argon work suggested that this site had an age of on the order of 2 million years, which was quite a bit older than the prevailing thoughts. This site, these ages were disputed in the archaeological, anthropological literature. At that time, some zircons were sent to Bob Fleischer at the Schenectady General Electric Lab, who dated zircons from volcanic ashes, similar to what we were doing in Mexico, at the Olduvai site. And he got, actually, I think it was glass, excuse me, he dated glass from that site and got ages on the order of 2 million, which is very much close to what everybody else is getting now. And it pretty well settled that early man had been in Africa for at least 1.8 to 2 million years, and now we know it goes back much further.
The discoveries at Olduvai and Valsequillo were made at the same time and tested with the same dating methods. The African site changed human history, but the Mexican site was virtually forgotten.
As a Native American Studies professor and a person who teaches North American and Central American archaeology, one of the most aggravating, most exciting, and most inspiring sites, I think, for me to teach is a site called Valsequillo. It's important to me for several reasons. First of all, I've worked a lot in Mesoamerica. But secondly, it represents an absolute impossibility in North American archaeology. It's got three completely impossible things. The first component is basically, do we believe in our archaeologists? Do we believe that our archaeologists know what they're doing, how to dig, and their theory? And Valsequillo was dug by one of the foremost North American archaeologists many years ago. Her name was Cynthia Irwin-Williams, passed away several years ago. I've worked with her in the Southwest, and everybody that I know respected her as one of the great dirt archaeologists and archaeological theoreticians. So the possibility that whatever she found at Valsequillo is not being real in terms of the context and the excavation of it, I can't see that as even a remote possibility. The other part is, as a scholar that likes to deal with dating and geochronology, there's an almost impossible contradiction between Cynthia Irwin-Williams' discovery and the tephra chronology, the chronology of the overlying or associated volcanic deposits that have been dated many hundreds of thousands of years ago, way before we believe that the archaeological materials at Valsequillo could be made. And then you've got the third thing, the third issue, is the age of human beings coming into the New World. Of course, when I was a graduate student growing up, I was taught that Clovis was the earliest period. So we were looking at 11,005, maybe 12,000 years ago. Now we're pushing it back, of course, to the 15,000s. But certainly, I don't think there is a living archaeologist that would ever hold to the idea that people were here 200 or so thousand years ago. So what we have is not a dilemma, but what I've always called in my teaching a trilemma, a triangle. Any two of these components can be true. Cynthia can be right, and the dating can be right. An archaeological theory about the origin of people in the New World is wrong. The origin of people in the New World is right, and the dating is right, and therefore Cynthia Irwin-Williams was wrong. Or Cynthia Irwin-Williams is right, the origin and development of population in the New World is right, and the dating is wrong. Well, I just don't see how you can deal with that, because the dating was done by tephrochronologists that I respect and understand. The archaeology was done by archaeologists that I respect and understand. And as a practicing archaeologist, I am not going to go against archaeological method and theory that's stating basically that people had to come in somewhere after maybe 30,000 years ago. So this is a completely fascinating, completely aggravating, completely wonderful site to teach about. Because, as I said, any two can be right, but not all three. And so something, at some point, is going to have to give with reference to Valsequillo. And I don't know which it is. I just hope that my first choice would be to have Cynthia Irwin-Williams be proven correct. Second choice would be I would hold to the tephrochronology and the geochronology of that. The one that I would feel the least affinity for and be willing to revise is the idea that people came into the New World relatively late.
The next step of the investigation was to determine which leg of the trilemma should be revised: the archaeology, the geochronology, or the theory of man's arrival in the New World. Marshall Payne decided to first examine the geochronology of the volcanic ash to find out if it was indeed 250,000 years old. He began the process by sending the original Hueyatlaco reports to several geologists.
And back came the reports, and they all said the same thing. They said that the geology looks sound, but if you really want to be certain about this, you should use techniques that are available today that were not available 30 years ago. So we gathered a couple of 100 pounds of that material, and the Mexicans shipped that material up to Stanford University. And at Stanford there was a man named Trevor Dimitru who agreed to reduce all these bags of material down to items which are datable.
The datable material is basically crystals of zircon, so they're little sand-sized crystals of the mineral zircon, and they have small amounts of uranium in them. And the decay of that uranium permits them to be used for determining ages of rocks.
Half of the material that he reduced was sent to a man who is now at the University of Idaho, who is an expert in fission tracking. The other half went to Caltech, to a man named Ken Farley, who is the originator and the expert on another dating system used in geology called uranium, thorium, helium dating.
In a zircon crystal, we can calculate the age of an eruption event if that zircon crystal occurs, for example, in a volcanic rock. The fission track dating technique concerns itself only with uranium inside that zircon, which is trapped at the time of crystallization, okay? And it looks at the uranium and the formation of these fission tracks due to the spontaneous atomic splitting or nuclear fission of the U-238 isotope. And those fission tracks form all the time, whether that crystal is in the magma and hot or at the surface and cold, okay? If that crystal is at the surface and cold, that crystal will accumulate fission tracks. They won't disappear due to heating. They'll just constantly add up through time. So the clock is the fission tracks accumulating. The ages that I have for this volcanic layer tell me that these rocks cannot be younger than about 250,000 years. My ages are minimum ages, not maximum ages. And so where my uncertainty in the results that I've generated resides, it's in why did I not get ages closer to Ken Farley's 400 to 500,000 year ages? I believe I have reasons, and I describe that both in the paper we intend to publish on this, and we've discussed this before. It has to do with the difficulty of working with these samples. But what I saw in terms of the number of these daughter product fission tracks, when I count, say, 100 of them, there are 100 there. And if those 100 tell me 250,000 years, then maybe there were another 50 that I didn't see for some reason, then that would add another 125,000 years and make it closer to 400,000 years. But I did not add 50 in accidentally. I saw 100 and there were 100 there. So my ages are a minimum. There's no way these rocks are younger than 250,000 years. Put it this way, there's no way the zircons are younger than 250,000 years.
You know, a criticism that is easily made is that the zircons within the layer are older material, that say a volcanic eruption occurs and it stirs up, you know, older material, and that cannot be directly constrained by the dating method. Now I think, you know, from what I've seen of this data, that doesn't appear to be the case.
In an effort to explain the seemingly impossible age of 250,000 years for the Hueyatlaco ash, the latest fission track techniques were applied and corroborated Chuck Naser's earlier findings. The team next went to Caltech, where Ken Farley used his uranium, thorium, helium dating method. His test results were even more astounding.
Uranium, thorium, helium dating is a very old idea. It goes back to the discovery of the alpha particle, the first particle discovered to be a radioactive product. It's based on the idea that when uranium decays, it produces alpha particles at a known rate, and by measuring the amount of alpha particles that are present in a crystal, one can establish how long it's been since the helium began to accumulate in that crystal. I was contacted by Ray Donelick to work on a project that he was involved in, which was to establish the age of a volcanic unit by dating of zircons. And Ray Donelick had used the fission track method and proposed that I use the uranium, thorium, helium method to try to date the same formation. And the advantage of the uranium, thorium, helium system relative to the fission track system is that there are a lot more alpha particles produced than there are fission tracks produced, and so you get a much larger signal, which is important when one is trying to date very young samples. So I was sent zircon separates, which I analyzed here in my lab. The analysis involves picking out a few crystals from the population of crystals I was sent, heating these crystals to 1300 degrees C with a laser or with a resistance furnace. The helium comes out of the crystals at that temperature by diffusion. We then retrieve the crystals from the vacuum furnace after the helium is analyzed, retrieve them from the furnace, dissolve them, and analyze them for uranium and thorium by inductively coupled plasma mass spectrometry.
I exacted blood oath promises from these scientists that they would not communicate with each other until I had their results in my hand. And they agreed to do this, and in fact, that's what they did.
The zircon crystals were sent to me blind. All I was told was that the crystals were likely to be young, which is an important thing to know when one sets about making an analysis. One needs to know about what to expect just to figure out how much sample to analyze. So I was prepared for the samples to be young, analyzed the samples, produced an age which was between 400 and 500,000 years, and that is slightly older than the age that was obtained by Ray Donelick by the fission track method. And I think within the uncertainties of these measurements, that's probably not a big surprise. In particular, the fission track method has relatively limited resolution at young ages. So the ages are somewhat different, but I don't think they are different beyond a reasonable analytical error. Whether or not that agrees in detail with the fission track method, you'd have to ask Ray Donelick about what the origin of his uncertainties are.
I do have certain reservations about the data. I'm quite convinced that Ken Farley's ages are probably closer to the true age of this volcanic rock than my ages. And that is largely due to the higher precision of his methods, and he was able to reproduce his results more closely than I was. I tried to do reproduction of my results, but these samples are so difficult to work with for fission track dating methods that we're right on the edge of whether we can analyze them or not.
So the date that I've been using as a compromise between the two is 300,000 years old. And if I had to bump that someplace, it would be up.
To explain to you why I think I would favor the helium age over the fission track age is for every fission decay that he can count, there are about 10 to the 7, 10 million alpha particles produced. And so since he has very few particles, very few tracks to count, in comparison to what I have, I've got 10 million more that I can measure.
Since the age of the ash appears to test to at least 250,000 years, the next question is, has the relationship between the Hueyatlaco ash and the artifacts been properly identified? The team examines leg 2 of the trilemma, the archaeology. Throughout the years that Cynthia was excavating, her team developed a geological model that showed that all the levels of accumulated sediment were laid down successively on top of one another, like a layer cake. All the artifacts and associated bones were excavated from strata below the Hueyatlaco ash. Geologist Hal Maldi went back to the site to retest the stratigraphy.
So I didn't go back until 1973, and our purpose then was to do a geologic excavation, not an archaeological excavation. So maybe the best way to explain that is to look at this photograph, which was taken in 1973, looking at the Hueyatlaco site on the eastern side of the Tutela Peninsula. Here we're looking to the south, and in the photograph we can see the area which Cynthia had excavated in the early 60s, and where she found artifacts and certain bone remains. I acted primarily as a surveyor, and Virginia Steen McIntyre did some sampling, and the primary investigator was Roald Fryxell, who was a professor at Washington State University. Fryxell had a lot of experience working with archaeological sites, so he was skillful in identifying what we call stratigraphic units, or individual lithologies, and units of a particular characteristic. And he drew those in his profile sketches, sort of like looking at the wall of a canyon. He would draw the individual layers that could be seen. He also did a technique that is very common among soil scientists, namely he took monoliths. These would be, so to speak, cemented to planks of wood and therefore preserve a portion, a vertical section in the bedding that was seen in these trenches. The bottom line on this is that we were trying to determine whether, strictly on the basis of the stratigraphy that would be exposed in these trenches, whether there was continuity from the place where Cynthia had excavated in the 60s and the uppermost part of the exposed geology. And in fact, that was the result. We found that it was layer after layer after layer, with no interruption, no discontinuities, no places where there was any downcutting. A simple set of individual units, one on top of the other, from where Cynthia had dug all the way up to the top of the section. So that really finished our 1973 investigation.
Now, when you say you check the continuity, does that mean that the layer with the artifacts, which was under the layer with the volcanic ash, that the artifact layer is older than the volcanic ash layer?
Layers of sediment are laid down one on top of the other unless there's some aspect of dissection in the meantime. And in this case, it's simply one leaf of the geologic time on another leaf of the geologic time.
In the first leg of the trilemma, the geochronology says the age of the Hueyatlaco ash was at least 250,000 years old, and some tests gave an age of over 1 million years. The second leg, the archaeology, bears out that the artifacts appear to have been found in a sequence of strata, which is entirely overlaid by the Hueyatlaco ash. If these two legs of the trilemma are correct, this means that modern bifacial spear points were made in the New World, 250,000 years ago. It's time to examine the third leg of the trilemma, the theory of man's arrival in the Americas. According to the prevailing archaeological model, modern man occupied North America around 15,000 years ago and migrated into South America around 12,000 years ago. To date, most of the evidence found by archaeologists supports this scenario. But what happens when evidence is found that does not?
If you can imagine that 22,000-year-old dates were controversial, put another 0 on that, and all of a sudden we're coming out with really nice spear points that nowhere else in the world were found at that antiquity. This was a huge problem. So Cynthia really didn't know what was going on. She wondered about the nature of the dates, how this could possibly be credible. She thought the dates were silly, out of the range of possibility, and she blamed the dating technique as not indicative of the dates that were coming out. And she discussed these problems with colleagues of hers, including Marie Wormington, and there are some letters that have survived that discuss this type of quandary that she was in. I recently got a letter from Hal Maldi with some incredibly wild uranium dates on the Valsequillo material. I don't see how we can take them seriously since they conflict with the archaeology, with his own geologic correlations, and with a couple of C14 dates. However, God help us, he wants to publish them right away. I'm enclosing a copy of Hal's letter and my reply. Needless to say, any restraint you can exercise on him would be greatly appreciated. All we need to do at this point is to put that stuff in print, and every reputable prehistorian in the country will be rolling in the aisles.
In the audience was a geophysicist by the name of Barney Szabo. He came up to me after hearing my talk and said, I'm doing research on a dating method called uranium series dating. Do you have some samples that I could work with? When he got these results, it turns out that the Valsequillo material seemed to be about 250,000 years old. And when I told Cynthia Irwin-Williams about this, she sort of blew her top. She couldn't believe that this was so, and she thought that it was improper to publish the results. But Barney was very concerned about getting this information out into the scientific world for review. So as a result of several conferences, Cynthia agreed that we could publish this, but in a place which would not be seen ordinarily by archaeologists, which is a rather peculiar ploy. But and meanwhile, she would also provide sort of an internal rebuttal. Part of my confusion at this time was that it seemed very difficult for me to rationalize these old dates with my understanding even of the archaeological context. So that led to the use of the word dilemma in the paper that we used to announce to the scientific world these old dates determined by the uranium series method. I think as a result of that, Cynthia really gave up on the site. 1966 was the last time she was down there. And she, let us say, washed her hands of doing any further publication. We got no feedback from her about anything further about her results beyond what she had already published, and things really came to a standstill.
As a result of these controversial dates, Cynthia Irwin-Williams never returned to Valsequillo. All of her artifacts and most of her field notes have vanished. Juan Armenta was forbidden to return to the site, and all his artifacts were confiscated. Irwin-Williams never published the final results of her 6 years of fieldwork. So which of the three legs is wrong? Some experts in the field believe they have found an explanation that could solve the mystery of the trilemma. Geologists call it an unconformity. Dr. Michael Waters is the director of the Center for the Study of the First Americans. He has worked on more than 50 archaeological field projects and is well known for his expertise in geoarchaeology.
Valsequillo and Hueyatlaco always intrigued me because it was one of the localities that had the possibility of strong evidence for pre-Clovis occupation in the Americas. And so I read about the excavations that were done in 62, 64, and 66 by Irwin-Williams. I met Irwin-Williams a few times. And then I read about the work that was done in 73, and then discovered about the research that you found.
Which model is correct? In Christopher Hardiker's new book, The First American, he cites a letter that Williams wrote to Armenta in 1989. In this letter, she explains the impossible dates found at Hueyatlaco by proposing that an unconformity accounted for the extreme age of the artifacts.
So it became very obvious the thing that had to be done is to go back and dig it again. But this time, at the site, as the dig was being conducted, the professionals that were needed to analyze all these notions, and especially this idea of the undercutting of the stream.
June 15th, Bob McKinney came. He's in the blue shirt.
Bob McKinney received his degree in geology from MIT and has been working with oil and mining companies for the past 40 years. Bob examined the monoliths taken from Hueyatlaco by Roald Fryxell in the mid-60s. He compares them with rock samples he has taken from the field to determine if the Hueyatlaco ash overlays the beds the artifacts were found in.
This is as if you were to take that whole trench and bring it home with you, but you can't do that. So you take one slice out of the wall of the trench, glue it to a board, and bring that back so you can study it just as it was in the outcrop.
You can see the location of some features which we called monoliths, which Fryxell collected as stabilized columns of sediment in their original position. And these were spaced in such a way so that they overlapped stratigraphically, going from one down to the next step, down to another step, down to another step. And this was done all the way down into the area where Irwin-Williams had done her digging.
You can just loosen it up and take it off.
The idea behind looking at this particular section, the top end of this is down here, the bottom end is down there. The top end is actually in the tephra. Here's a sample of that rock, and this is the tephra. This is the volcanic ash that has been dated radiometrically. And the idea here is to take a look at this continuing section, which has not been reassembled or anything. This is just exactly the way it was when it was pulled out of the side of that trench. So we have this length of stabilized section taken from a trench located about 20 to 25 feet from where the fossil remains were found in this particular kind of rock. There is no question in my mind from a geological point of view that the zone that contains the artifacts was not incised by a more recent stream. And to do this, to prove it to ourselves, we have traced that zone from underneath the overlying tuff bed, which is a very good identifying marker, all the way back around the front of the area that's being benched right now, up to a trench that goes back underneath it, and we've followed this bed the entire way, and it is not interrupted, not incised by anything. Therefore, the strata that contain the bifacial tools and together with the bones has not been disturbed at all. The important point here is that the section that we examine is the section in which the fossils were found. It was not eroded, it was not redeposited. Those samples are right, those tools and everything else are right where they started.
The monoliths, Fryxell removed and preserved, turned out to be valuable assets to the investigation. According to Bob McKinney's analysis, they proved that the artifacts found by Irwin-Williams were in strata beneath the Hueyatlaco ash. However, Mike Waters found evidence to the contrary.
So what we did is we excavated a trench, my Mexican colleagues and myself, which would expose this area right in here, which would be one wall of Cynthia Irwin-Williams' excavations. And then in addition to that, we excavated another trench going this direction to find again the other side wall of our excavations, and we did find the end of our excavations, which had been taking place out in this region right here. And then we extended that trench up the hill to where it intersected and came into contact with the Hueyatlaco ash. This way we could then examine the layering, which we call stratigraphy, from the Hueyatlaco ash all the way down through the profile in this trench and out into Cynthia's excavation area. And therefore we could see if any of the units went underneath the Hueyatlaco ash or were unconformable against the Hueyatlaco ash and therefore younger. The cross-section that we'll take a look at now is this wall right here, and it extends from her excavation area, you know, and then up here to where the Hueyatlaco ash is located. What you're looking at is this would be Cynthia Irwin-Williams' one of her excavation walls right here. And what we did when we did the mapping here is, like any stratigraphic project at any archaeological site or anywhere, is you just objectively define the units. You use textural analysis, cementation, the bedding structures, you know, the undulatory topography, the cross-cutting relationships of units to define different stratigraphic units or define the layering within the sequence. And when we did this, we were able to come up with this sequence showing, you know, the Hueyatlaco ash here, and then underneath the Hueyatlaco ash was a very thick section of floodplain sediments, old riverine deposits. It was a vertisol, which is, you know, vertisol is a clay that expands when it's wet and contracts when it's dry. And then underneath that were more fluvial sands, okay, were probably channel and bar type sediments. And those channel sands extended all the way out into our excavation area. And then erosionally on top of that, there must have been a period of erosion at some time because those sands were truncated, and you can see old channels like this, and then a channel comes down here, and this channel actually was multiple channel fills in it with gravels, you know, cutting into the top of bed I. Then it came up like this and actually truncated the older stratigraphic units, including the vertisol. So what you would have had at this site, you would have had fluvial deposition, which is riverine type deposition, when all these sands were laid down. Then there was floodplain deposition here, in which you had the vertisol formed. The Hueyatlaco ash got on the top of that. Okay, it was deposited as airfall ash. And above that, there's some additional sediments, but they weren't mapped in because we only took our section to the Hueyatlaco ash. And then sometime after that, there was an erosional event, you know, again, a fluvial event where a channel cut down and truncated, you know, all the older deposits, and then new channel sediments were deposited, okay? Now, in correlation with what Irwin-Williams found back in the 1960s, once this cross-section was made, we got out her old cross-sections that she did back in the 1960s, because we wanted to find out, okay, of the units that we defined, can we identify bed I, where she claimed she found the unifacial artifacts, you know, and can we find beds C and E where she found the bifacial material? And, you know, fortunately, we had several places where her cross-sections, which would actually be coming this direction, cross-cut, you know, our profile. And when we did this, we were able to identify that this was more than likely what she called bed I. And this is, again, where she claimed to get the unifacial artifacts from. And bed I comes like this, okay, and extends across in this direction, pinches out in this direction, just like many geological units do. But it's also overlain by kind of a silty sand deposit, which then is overlain by this vertisol, which is also overlain by the Hueyatlaco ash. So very clearly on stratigraphic grounds, we can say that bed I is definitely underneath the Hueyatlaco ash. But one thing that we did discover, and it was, you know, pointed out by Cynthia Irwin-Williams, was that there was an erosional contact which separated what she called the unifacial material from the bifacial material, okay, as she reported it. And we very clearly found that erosional contact, just like she had reported, and that erosional contact comes up in this direction, you know, and cross-cuts and cuts across the older vertisol, indicating that this is a much younger unit, unrelated and younger than the Hueyatlaco ash. Now, the interpretation of the geology that was made in 1973 by Maldy and Fryxell and Virginia Steen McIntyre, we've confirmed part of that stratigraphy and then are at odds with other parts of that stratigraphy. And the part that we confirmed was the fact that bed I does indeed go underneath the Hueyatlaco ash. But where we differ is that they believe that these deposits, which would be the equivalent of Irwin-Williams' units C and E, also went underneath the Hueyatlaco ash. And they would not have, they didn't recognize this erosional contact. Instead, what they saw and they felt was that the geological deposits came this direction and then kind of disappeared into this vertisol. But the work I did, you know, indicated that very clearly there was an erosional contact separating this from that, and that this unit containing the bifacial material had to be younger.
Waters looks at this contact here at the base of the channel and extends it up into thin air and makes it unconformable against the higher deposits, including the Hueyatlaco ash and the higher units. There's no physical basis that can demonstrate that these deposits lie against or on the Hueyatlaco ash. That information doesn't exist because it's been lost by erosion, if it ever did exist. What does exist, however, is physical evidence that is still preserved. And later on I will show some photographs which show how these channel deposits, 2 meters thick, were topped out or capped out by subsequent material which accumulated first on the stream bank here as in an area which I call a levee, and which spilled to the south as finer and finer material in a floodplain, which makes the levee and the floodplain continuous as the latest member of the channel fill here. and also places all of this material below the Hueyatlaco ash, the overlying clay, the tillip-brown mud, and the Buena Vista lapilli. In other words, we see here a simple stratigraphic sequence from unit I, the sterile material that overlies unit I, a channel only a couple of meters deep, cut down into those deposits, capped off with overbank material during flooding of the stream, forming a levee and a floodplain, subsequently filled the area, then accumulating more clay, the Hueyatlaco ash, more clay in the higher deposits. The reality of this can be seen because it's still in the ground. This is what we exposed in 1973 and preserved by backfill in the trench.
If you look at the photographs here, you can clearly see this erosional contact. This is to be the vertisol right in here, and you can see the contact coming down here, cross-cutting and cutting the vertisol and coming down that way. You know, this is just a better photograph of this, showing the structure that's in that, you know, floodplain vertisol, but you can clearly see the erosional contact coming up like this. And that contact is this contact you see right here. Okay, and then it kind of comes on down that direction. But anytime you have a situation where you have something like you're following a contact like this and you've got clay, and then you cross an abrupt contact like this, it's almost vertical or very high angle, and then you go into something that's completely texturally different like a sand, it's telling you that something has happened here. And geologically, you have to evaluate this to determine whether you have an erosional contact there, separating them, meaning this is older and this is younger, or is there some sort of relationship here where this is grading into that? And as I say, in '73, they thought this was grading into that, but I think you can very clearly see in this photo that this is a very sharp contact with clay on this side and sands on that side, and that this contact comes up in here or it's been disturbed by vegetation. But very clearly this is younger than that. I think the reason that might have happened is even when I was out there, I noticed that that part of the section in the vertisol tended to dry out a lot quicker, and when it dried out, it obtained kind of a whitish color, you know, similar to the sands. And so as you come up here, you can kind of see that same contact I was mapping in the erosional contact. And then in '73, what they did is they went with the color, I think, and came across this way and mapped the sands grading into the clays there. But in reality, if you look at this photo, I think you can see the contact, and the contact comes up like this. And what you see in here is a drying phenomenon. You can still trace, if you look closely at this photograph, the structure of the vertisol coming in this direction and coming up this way. But then when you look at this part, which are the sands, you can't see any of that soil structure. So I think even in the '73 photo, you can pick up that same contact coming up just like this between the pure sands and the clays.
This is a photograph made by Roald Fixell in 1973. It is a place where Mike Waters, in an interview that he gave a couple of years ago, discussed what he calls a drying phenomenon. He was beset because of the location of his unconformity going up to the ground surface with dealing with the similar degree of coloration or lightness, if you will, of the area across where he drew his unconformity. As I understand it, he would draw the unconformity from this contact and he would take it up to the ground surface. That's the way he kind of pointed it out in his interview on video. And so he was had the problem of dealing with this material in here being fairly light and this material over here being fairly light, although he wanted to make the deposits on the two areas stratigraphically different, making this an older area, making this a younger area in his channel. So he came up with the expression drying phenomena. And as I understand what he's driving at is that in order to account for the similar degree of lightness, he said that this area here, which he thought was older, had dried out in the same way that the material here had. And therefore, there was, in his view, a spurious continuity across what he took to be a contact, a spurious continuity between material here, which he thought was young, and material over here, which he thought was old. Now, our interpretation, of course, is entirely different. We see it not in terms of continuity of color, but in continuity of bedding. And that's why it's important to recognize that Fryxell, in order to bring out that bedding, scribed the bedding planes going from this area down to here. And therefore we see this as a continuous layer, although changing in texture from sand to clay.
Another thing is when I examined this contact in detail, because I knew there was going to be some concern about and controversy over this contact, is that in the lower portions of the vertisol here, there were small little shallow channels of very fine sand. There were some sandy clay deposits in here. There were some pure clay deposits. There were some sandy, silty clay deposits that had accumulated within a very small little channel here. And each one of those deposits, the clay could be traced over here, where you again had clay along this contact, on that side of the contact, and sands on this side. And again, you had clay on this side and sand on that side of the contact. And so this area would tend to dry out a little quicker than the rest of it, this being pure clays, this having some sand in it. And so it would have led to that idea that this unit actually extended off underneath the vertisol. But very clearly, I think you can say there's a clear separation, erosional contact between the units that contain the bifacial material and the other units that supposedly contain the unifacial material.
Classically, a vertisol is characteristic of a climate which has strong periods of wetness and strong periods of dryness. And of course, it has to form in a clay, and it's a soil property. It starts from the ground surface, works its way downward, and the mechanism is alternating swelling and contraction of the clay under the influence of being wet and dry. And a result is that a vertisol has very strong vertical mixing, and which obliterates all signs of bedding. But note that there is this bed over here, light colored. It starts on somewhat higher ground, dips to the south, kind of flattens out, just as the Levy model says it should. And this light colored layer is a bed. But here's another bedding feature in what Mike would call a vertisol, and therefore an area in which all bedding should be obliterated by the vertical mixing, which is characteristic of vertisol.
In summary, bed I would go underneath the Hueyatlaco ash and therefore be older than the Hueyatlaco ash. How much older? I don't know. Probably not that much older, because this sediment package could accumulate very quickly. But this erosional contact indicates very clearly that this postdates all these other older fluvial deposits as well as the Hueyatlaco ash. And so therefore this is younger than the Hueyatlaco ash, the units what she called beds C and E that contain the bifacial artifacts.
Despite the conflicting theories about the relationship between the Hueyatlaco ash and the unconformities, both parties agree that the Hueyatlaco ash overlays bed I. The question now remains, were the unifacial artifacts reported by Cynthia Irwin-Williams actually found in bed I?
If artifacts were found in bed I, and it's very clear that bed I goes underneath the Hueyatlaco ash, then are we dealing with artifacts that are, over 1 million years old? And I think the answer to that question is no. because some of those artifacts are more sophisticated than what you see even in the old world. We were able to find all of Irwin-Williams's excavation records, or a large number of her excavation records. And so we took each one of her excavation lines and began plotting various ways that she identified, you know, beds E and F and G and I and all the other layers that she defined. And in one set of notes, we found that they would contradict with other sets of notes, and then notes written on artifact drawings would indicate that it came from bed I, but then you go back to the records and it came from bed G, but then you see she scratched out bed G and changed it to bed I. So there seemed to be a lot of jockeying going on as to where these artifacts came from. And one thing that we noticed is that when you put these things onto a spreadsheet here, is that many of the artifacts that were found, and there weren't that many found within bed I, were found right on the contact of this unconformity. So in other words, you might have bed I right underneath the unconformity, and there might be an artifact and it might just be a slight distance, you know, no more than 10 centimeters below the unconformity.
So you're saying most of the recovered artifacts were close to the unconformity?
Right, and so I think maybe what had happened is when, you know, this is a very geologically complex area with a lot of cutting and channel cutting and filling, and it's hard enough to see when you're looking at it in cross section, but imagine you're an archaeological excavator and you're coming down on it horizontally, you probably wouldn't pick up on all these subtle unconformities because they're fine-grained sands on fine-grained sands that are cutting in and out. And so any kind of unconformity would have been recognized after the fact. And it's also kind of interesting that some of the artifacts that are attributed to bed I, like this one here is directly underneath bed E, but then this one that also came from, quote, bed I here, was once assigned to bed E and then to bed G and then eventually down to bed I. So she kept changing her nomenclature.
Going deeper into section as she went.
Yeah, or just actually, they were recovered from a position during the excavation, but then she would just reassign them to bed I sometimes. And this recurs over and over and over again in her excavations. And if you look at the artifacts that were recovered from above the unconformity that she defined, you know, which was the same unconformity that we found a little over a year ago, and what was found beneath it, there aren't really that many differences. You know, you think that the material that came from bed I is all unifacial, but when you really look at it, it's not. They are bifacial artifacts in there. And there's some that look identical to what was found above the unconformity. So what I think's going on is that Irwin-Williams probably did not find those. She thought she found those artifacts in bed I, but they were really coming above the unconformity, which undulates quite a bit.
Yes, Irwin-Williams, to repeat, never really wavered as to the physical position of the artifacts. She recognized that say, a unifacial artifact was in this part of the section. In 1964, because she was looking at this kind of flow roll contact in here, she had used that as a basis of choosing to name this part I and this part G. But when she found this contact over here in 1966, she decided, no, that was a mistake, that really this and this were all part of bed I. She didn't move the artifacts, she didn't waver on where they came from, she just refined the naming of the unit.
Did an ancient river carve a channel 11 meters deep through the Hueyatlaco ash and the beds below it, explaining how the artifacts could have been found where they were? Or did the volcanic ash cover and shroud the man-made artifacts and butchered animal bones sometime over 250,000 years ago? A surprising answer to this dilemma may be found in the single-celled body of one of nature's tiniest creatures. Diatom, any of various minute, unicellular, or colonial algae of the class Bacillariophyceae, having siliceous cell walls consisting of two symmetrical parts. Sam Van Landingham is an environmental geologist from Midland, Texas, whose expertise is using diatoms to date the age of rock strata.
And he can go into a strata, he can take a sample, he can find these little things called diatoms, which are microscopic, and with his 40-some years of experience, he is able to tell which diatom this is, when it existed, and when it didn't.
Some of these diatoms, some of the types that are in here, are still living today. And some of them are not. Some of them died out over 80,000 years ago, and those are the ones that I'm trying to find.
First, we need to know, Sam, what are diatoms?
Diatom is a tiny one-cell microorganism, and it's enclosed in a siliceous or glassy skeleton, and it's highly ornate, and you need one of these microscopes to be able to see them.
An artifact is dropped on the ground near the edge of a stream. The water level rises, surrounding the artifact with living diatoms. When the diatoms die, they sink to the bottom and become part of the sediment. Over time, the sediment builds and covers the artifact. This process is repeated and new beds are formed, each containing unique communities of diatoms. Long after the water has receded, geologists can determine the age of the various strata by analyzing the diatoms which are present.
Sam has dated the layer that we find the artifacts in with diatoms.
To get a good date based on diatoms, a person who studies algae or microorganisms would need to find several of these microorganisms in the sediments.
Okay, so what that means is that in the identification process, you are able to relate that to the age of the sediment that you find them in.
Many of the samples have overlapping ranges, and we can get good dates from them, and, very frequently, which is quite unusual. In fact, it's one of the best areas in the entire world to date sediments with diatoms.
Diatoms have an extensive fossil record, going back millions of years and existing in various forms through the present day. Some of these amazing microorganisms have a lifespan of only minutes or hours, yet many of the species have remained unchanged for millions of years. Periodically, whole species will die off, never to be seen again in the geologic record. When those species are found in rock strata, it gives a minimum age for that strata. Deep in the ground at Hueyatlaco, where all the artifacts were found, hundreds of species of extinct diatoms were discovered, including Navicula cryptocephala and Cimbella cistula. According to Dr. Van Landingham, this means the strata is of Sangamonian age, a minimum of 80,000 years old.
The diatoms that I studied at the Hueyatlaco archaeological site are well known to geologists and paleontologists. They died out over at least 80,000 years ago, over 80,000 years ago.
You're saying that the diatoms that you ended up testing were taken from the exact place that the artifacts were found?
Right, that's correct, yeah, no question. That would indicate to me that the artifacts found at the Hueyatlaco archaeological site are over 80,000 years old. Yeah.
The biggest question that needs to be resolved as well is this, the diatom evidence.
Yeah.
Because Sam Van Landingham, who I've never met, has examined the diatom assemblages from below the unconformity and also above the unconformity. Yeah. And he finds no difference between the diatoms here and the diatoms over here.
Yeah, that's right.
And that does present an issue that needs to be resolved. Yeah. But I remember in the original manuscript, he always talked about that the Sangamon age was a minimum age.
Yeah.
And so if that's the case, then maybe there is no conflict here, because that's where the diatom assemblage, could maybe it's Sangamon or maybe it's older, because that's what a minimum age means. So maybe there is no conflict. But where the conflict would come in would be finding those diatoms in the younger sediments above the unconformity. And I think the thing that needs to be worked out here is see if we can get better geochronological or any geochronological dates, from above the unconformity. And that's, something that needs to be considered over here in the younger deposits. Are there younger diatoms? Are they in the same condition? Are these more degraded and these less degraded? And do they occur in the same frequencies? X percentage of this type diatom and the same percentage over here consistently. Mm-hmm. And those are the kinds of things that I'm not a diatom expert, and I'll have to read the report.
The study of diatoms is a very, very esoteric study within the discipline of geology. Hardly any geologists know about this stuff. Sam's evidence is that there is a family, not just one, but a whole family of diatoms in the inset that are identical to the same family outside of the inset. And we know that both of these families have been extinct for at least 80,000 years and very possibly hundreds of thousands of years. So how is it possible for an inset to be younger than the material right next to it if they contain these same diatoms?
What makes Dr. Van Landingham question the existence of an unconformity is the fact that he found multiple communities of extinct Sangamonian diatoms on both sides of the disputed contact. Some have described the Enigma at Valsequillo as a trilemma, comprised of archaeology, geochronology, and the theory explaining man's arrival in the New World. With this trilemma, only two of the three legs can be right. One camp says the archaeology is impeccable, the geochronology accurate, and therefore the theory must be wrong. Another camp says that's impossible, that the geochronology is accurate, the theory of man is valid, and they challenge the relative position of the artifacts.
What if we are dealing with something very old?
Well, I really doubt that, because it would mean that you have really well-made bifacial artifacts like this at 1 million years. And you look anywhere in the world at 1 million years, and what are people making? At 1 million years, they're making Olduvai tools, and at best maybe primitive hand axes. And it just would make no anthropological or archaeological sense that people at 1 million years in North America would be making nice bifacial spear points.
Yeah.
And if they had been, then the rest of human evolution should have taken place in the New World, and people should have back migrated into the Old World.
I know very well that Mike's the expert, and I'm not. But on the other hand, I do have a scientific background, and I've looked at a lot of data, which compels me to think that this stuff is old. The next step planned is that everybody go back next spring, dig again, but this time with one single agenda, and that is to determine there's an inset there, yes or no. And Mike's agreed, and I have agreed that we will have at least 3 independent experts with no stake in this at all to evaluate the geology. There's an inset or there's not an inset. If there is an inset, all the old dates are moot. They're wrong. They don't belong in archaeology. If there is not an inset there, that would say that the old dates are accurate, and archaeology better take another look at early man.
At this juncture, it seems to boil down to one basic question. Is there an unconformity between the artifacts and the Hueyatlaco ash? If there is, then the current model of man's arrival in the New World remains intact. If there is not, the history of modern man, as we know it, may need to be drastically revised. As daunting as it may seem, the only way to resolve the issue of the unconformity is to go back and dig it again.
If it's real, the proof is out there someplace, and it'll eventually, if we're looking for it, turn up. If we don't look for it, we'll never find it.